Coming to the next application of potentiometer, calibration of ammeter. How to calibrate the ammeter by the use of potentiometer. A standard resistance is connected to the potentiometer. These two terminals are connected to potentiometers. First, a DC supply is required because it's a DC potentiometer. It is a DC supply is required. And fine and coarse adjustment. These are the similar to rheostats in DC RPS. Fine and coarse adjustment two rheostats to adjust the current through ammeter. Suppose 1 amp or 2 amps is flowing through the ammeter. The same current will enter to standard resistance also. How to calibrate ammeter and PMMC voltmeter by the use of Crompton's potentiometer or any potentiometer, DC potentiometer. Slide wire also we can use. The standard resistance, some portion of the standard resistance is connected to potentiometer. Some portion of the standard resistance is connected to potentiometer. Now the potentiometer measures what is the voltage drop across standard resistance. That potential voltage, unknown voltage equal to voltage drop or current through ammeter, and ammeter what is the voltage we given, that is the voltage across the ammeter. That means V into I is the voltage drop in ammeter. Similarly, what is the voltage drop or voltage unknown voltage we measured across standard resistance? We are comparing unknown current, the ammeter current and potentiometer voltage. The both are equal, then error is 0. Calibration of ammeter will be calibrated by this circuit. This application may be important. If you know every application, a standard resistance is connected. Previously also we connected a standard resistance. Measurement of unknown resistance also we connected a standard resistance S and unknown resistance is R. Two resistances we connected. After that, the potentiometer, when the potentiometer terminal 2 and 2 dash is connected, the standard resistance will be connected. Two potentiometer terminals. Two potentiometer in the sense the potentiometer unknown voltage will be given to potentiometer by these terminals. Hence, the voltage drop across standard resistance equal to voltage drop across unknown resistance. Then we are calculating R equal to VR by Vs into S. VR by Vs into S. VR is the unknown voltage drop across unknown resistance. Vs is the voltage drop in standard resistance, and S is the standard resistance value. Coming to another application of potentiometer. This is the calibration of voltmeter. Already we did the experiment practically also, Crompton's potentiometer, how to calibrate. By the use of voltage ratio box, we can calibrate potentiometer by the use of voltage ratio box for higher voltages. If the potentiometer voltage level is 1.5 volts, only maximum potentiometer voltage is. Similar to fine and coarse adjustment, a potential divider, coarse adjustment, fine adjustment, stabilizer DC supply is required. Because this is a DC potentiometer, we can give stabilizer DC supply. Coarse adjustment. After that, some voltage will be read by the potential voltmeter. That voltmeter reading, assume that it is a V1. Now the voltage ratio box step down the voltage level to according to potentiometer. Now the voltmeter is the voltage ratio box connected to 0 to 1.5 volts is connected to potentiometer. Now it will be measured. Now potentiometer measures means the unknown voltage will be measured. From that, based on that, we have to convert potentiometer reading into by multiplication back to voltage ratio box. That is the application of calibration of voltmeter. That is one of the application of Crompton's potentiometer or DC type potentiometers. DC type potentiometers are used to measure the not only unknown voltage, resistance and ammeter calibration, voltmeter calibration and voltage measurement, unknown voltage measurement. Coming to AC potentiometers. What are AC potentiometers? AC potentiometers are two types, polar type and coordinate type, two potentiometers. AC potentiometers not only measures the unknown voltage but also phase angle. V at an angle theta it will measure. Polar form, it is the principle of alternating potentiometer is same as that of DC potentiometer. That's why we have to know DC potentiometer also. The most important difference is both quantity, both magnitude and phase both will be measured. Magnitude and phase. V is the magnitude and theta is the phase angle. theta also measured. AC potentiometer is complicated instrument because of operation for that. It is necessary requirement of balance AC potentiometer. Requirement for balance of AC potentiometer is, it is very difficult. The vibrational galvanometer we have to use. The frequency of waveform of the current in potentiometer circuit must exactly the same as the voltage being measured. Usually detector used in galvanometer, vibrational galvanometer we are using. In DC bridges we are using tangent galvanometer or directional galvanometer, but in AC bridges we are using vibrational galvanometer. Similar to that, AC potentiometers we are using vibrational galvanometer. In AC potentiometers also we are using AC as a reference source. AC as a reference source, the absolute accuracy with which AC voltage can be measured. DC cell, standard cell is DC only. In AC potentiometer also the standard cell is DC. Now similar to that, standardization means adjusting the working current so as to match the voltage drop. After doing standardization, the instrument should not alter the working current. Working current means RH is the working current. You know that after doing the calibration, you can see in Crompton's potentiometer, after doing calibration, this rheostat RH, this working rheostat should not be altered after doing standardization. Only these two have to be adjusted to get null condition. To get balance, we are adjusting these two, fine adjustment working current only. Working current, this working battery produces some current that after calibration this should not vary. The 15-step dial and slide wire. Now we go for AC potentiometers. AC potentiometer, what are the types? I told you polar type and coordinate type. Polar type measures the instrument magnitude at an polar type potentiometer. This instrument measures the magnitude of unknown voltage, read from one scale, another one phase angle. Polar type potentiometer, because it is known as V at an angle theta, it will measure unknown voltage. Magnitude will be taken from one scale and theta will be taken from another scale. You can see the V1 is the V2 and V is the unknown voltage from theta. That coordinate type potentiometer, it is related to coordinate type potentiometer. These instruments are provided with two scales to read in phase component, out of phase component. These instruments are provided with two scales, one is in phase component and out of phase component is V2. From that we can calculate unknown voltage BEEE as given by V1 square plus V2 square total square whole square root. Phase angle theta can be calculated tan inverse V2 by V1. What is what is the construction of polar type potentiometer? The polar type potentiometer, also known as Drysdale polar type potentiometer, because we are using Drysdale phase shifting transformer we are using. The Drysdale phase shifting transformer gives the phase angle of unknown voltage. This instrument consists of an ordinary DC type and non-inductively wound Drysdale phase shifting transformer. It is non-inductive type, non-inductive wound Drysdale phase shifting transformer. Coming to the diagram, you can understand Drysdale polar type potentiometer. It is the Drysdale phase shifting transformer. Drysdale phase shifting transformer, because it also seems to be a motor, but two phase winding, single phase supply we are giving, and it is stator winding 1, stator winding 2, it is inductive, and resistance and capacitance are connected. After that it is a rotor having also some winding, it gives phase angle of unknown voltage. It consists of stator and rotor both. Stator is made up of silicon steel laminations provided with 2 or 3 phase windings, 2 windings or 3 windings. It is one winding, it is another winding, 2 or 3 windings. The rotor of transformer is also provided with windings in slots. The rotor also provided with windings in slots. When supply is given, the current flows through the stator windings, similar to motor principle. Whenever supply is given for stator, the rotor rotates the stator winding. The generator flux in the air gap. Whenever the rotor winding cuts the magnetic flux, an EMF is induced in rotor. This rotor position can be adjusted by adjusting the rotor angle of the phase displacement induced EMF. Whatever be the unknown voltage that we have to give for here, since supply voltage, the supply voltage will be given according to the unknown voltage. Unknown voltage, we assume that the V is of unknown voltage. According to the unknown voltage, the rotor shift, that is known as phase angle of unknown voltage. This is the Drysdale phase shifting transformer. It is one of the part of polar type potentiometer. It consists of one Drysdale phase shifting transformer and actual potentiometer. These two terminals are connected to potentiometer. Let us see what is the diagram of polar type potentiometer. This diagram also you have to draw for polar type potentiometer. Now according to that, the voltage and current equations, because in this we are connected, one phase is not connected to resistance and capacitance, one phase is not connected to resistance and capacitance, one phase is connected to resistance and capacitance. To give phase splitting will be possible if you connect a capacitor. A pure capacitor displays the current at an angle 90 degrees. It leads the current. Current leads the voltage by an angle 90 degrees if you connect a capacitor. Let us see that what is polar type potentiometer. From that, the EMF induced in stator winding, whenever the flux induced in stator winding or EMF induced in stator winding, K1 sin omega t cos theta. But in case of E2, it is a resistance and capacitance we connected, K sin omega t plus 90 degrees, cos 90 theta plus 90 degrees. By that, the resultant EMF is E equal to E1 plus E2. If you add 2, you will get E equal to Ki sin omega t minus theta. This is the diagram representation of polar type potentiometer. These two terminals are connected. To phase shifting transformer, Drysdale phase shifting transformer. Unknown voltage is connected to this also. Voltage to be measured is connected, and vibrational galvanometer we are using, and a fixed coil, Kelvin Verley slide wire we are using, and a standard resistance or R is the unknown some resistance we connected to adjust the working currents. That is DC supply is given. Under standardization purpose we are using DC supply. This is about constructionally what is that theory you can see. Constructionally, transfer instrument uses electrodynamometer type instrument we are using. In case of polar type potentiometer, we are using electrodynamometer type ammeter for doing standardization of potentiometer. The process of standardization of AC potentiometer can be obtained by switching the wire to DC supply. DC supply we are using. That means what is transfer instrument, already I told you. In DC supply is given to electrodynamometer type ammeter that can be calibrated under DC. After that ఎలక్ట్రోడైనమోమీటర్ టైప్ ఇన్స్ట్రుమెంట్స్ ఏం చేస్తారంటే ఏసీలో కూడా వాడుతుంటారు. అంటే డీసీలో క్యాలిక్యులేట్ చేసి పొటెన్షియోమీటర్లో అమ్మీటర్ డీసీలో క్యాలిక్యులేట్ చేసి ఆ తర్వాత ఏసీలో వాడతారు. కాబట్టి దిస్ ఈజ్ నోన్ యాజ్ ట్రాన్స్ఫర్ ఇన్స్ట్రుమెంట్. ద ఇన్స్ట్రుమెంట్ ఈజ్ యూజ్డ్ ఇన్ డీసీ, క్యాలిబ్రేటెడ్ అండర్ డీసీ. ఆఫ్టర్ దట్ వీఆర్ యూజింగ్ ఇన్ ఏసీ సప్లై మెజర్మెంట్. హెన్స్ ఇట్ ఈస్ known as transfer instrument. Dynamometer type instruments are known as dynamometer type ammeters are known as transfer instrument. Now operation with AC supply, the polar type potentiometer, the connection diagram and all you can see here. When the switch is positioned on the another position, when the switch is positioned to this position, unknown voltage will be connected. When the switch is positioned to this position, unknown voltage will be connected. You can give 1 dash, 2 dash like that. Then the switch will be connected to unknown voltage measurement, the phase angle can be measured. Now we can see another potentiometer, coordinate type potentiometer. Gall-Tinsley coordinate type potentiometer it is. Gall-Tinsley coordinate type potentiometer. Gall-Tinsley coordinate type potentiometer actually combination of two potentiometers. One of the potentiometer in phase component, out of phase component, that is quadrature component. Two voltages will be measured. The connection diagram for this potentiometer as shown in figure, it consists of two potentiometers. One is in phase potentiometer that is used to measure the in phase component of unknown voltage, whereas another one is out of phase or quadrature component can be measured. You can see the diagram. This is the representation of diagram. It is also important, either polar or either coordinate type. Anyone can come, it is important. Gall-Tinsley coordinate type potentiometer. It consists of two potentiometers. One is in phase potentiometer, another one is quadrature potentiometer. These are the two transformers, phase splitting circuit it is. It is two transformers, phase splitting circuit. When the switch is RS1, when the switch is RS1 is connected, unknown standard cell will be connected. Standard cell is the again DC. Vibration galvanometer used for unknown measurement. The two potentiometers, one potentiometer gives quadrature component and another one gives in phase component. From that V equal to V1 square plus V2 square. Square root of unknown voltage is square root of V1 square plus V2 square. From that tan inverse V1 by V2 by V1 gives phase angle of unknown voltage. Now what are the errors and measurement of frequency while using the same potentiometer either in DC and transferring to AC? There are some errors, frequency errors. The accuracy of methods of measuring, what are the errors present in slight difference will come while reflecting dynamometer type instrument as compared with recording on DC errors. DC, that is AC due to AC errors, due to DC errors. When the instrument is used for DC measurements, there is no frequency. When the same instrument potentiometer used for AC measurements, some instruments gives wrong reading, that is frequency errors will come. Accuracy of method of measuring frequency which obtained cause error in the quadrature or slide wire standard current volt value. అంటే ఏసీలో మరియు డీసీలో వాడతాం కాబట్టి ఒకే పొటెన్షియోమీటర్ని, అంటే స్టాండర్డైజేషన్ డీసీలో చేస్తాం అండ్ ఏసీ అన్నోన్ వోల్టేజ్ మెజర్ చేసేటప్పుడు ఫ్రీక్వెన్సీ ఎర్రర్స్ వస్తుంటాయి, అక్యురసీ ఎగ్జాక్ట్గా రాదు. అంతే డీసీ పొటెన్షియోమీటర్ వచ్చిన విధంగా ఇది రాదనమాట. అంటే ఎర్రర్ డ్యూ టు ఏసీ, ఎర్రర్ డ్యూ టు డీసీ, టూ టైప్స్ ఆఫ్ ఎర్రర్స్. యూ కెన్ సీ దోస్ ఆర్ ద ఎర్రర్స్ డ్యూ టు presence of harmonics also in AC, harmonics also present, that causes some error. Standardization of AC potentiometer. The DC potentiometer is standardized with the help of working current and rheostats with the help of standard cell 1.018 volts. Here we are doing standardization of AC potentiometer. This is all about coordinate type potentiometer. Applications of AC potentiometer.